says that a letter or more than one are called variables. So now you can have a variable. A variable is also known as a symbol. We use pi. Pi is known as a variable, and it is also a symbol. So we now are in algebra. Algebraic expressions do not contain equal signs. So it is always called an expression if it doesn't have an equal sign. So please highlight expressions, okay? And no equal sign. Not equal sign. Now we're going to talk about monomials. Monomial is a big word we use in grade 9, and it talks about the number of variables attached to digits, okay? So a monomial can contain numbers or digits in a fraction, or it can contain variables in a fraction. A monomial makes sure that every exponent on the variable has to be a whole number. So this year we're not going to deal with the negative exponents on top of those guys, even though we know we can. Okay? Monomial is considered to have one term. Mono meaning one. Okay? So each of these are sitting side by side really close, but really they're all separate. That's why they've got the commas. So if you take a look, we've got a 6 by itself. No variable, but is it actually a monomial? It's a special kind of monomial. Anybody remember the word that starts with C? Not that one. There's a different C word. That's always lonely, I say. This one's always lonely because he doesn't have a variable. The constant. Good. So the 6 is called a constant monomial because it has no variables. Okay, so that's the difference there. If we have a variable, it is still a monomial, but if it's a number by itself, we call it a constant monomial, okay? It's by itself, no variables. Then we take a look, and we've also got 6x. Now we've got a number in front of a variable. Who remembers what the number in front of a variable is? Somebody said it earlier. The other C word. Coefficient, good. The word co, okay, that first prefix, that C and O, co means in front for purposes of math, okay? So 6 is in front of the x, that's why it's a coefficient, okay? And we get into that stuff coming up, don't you worry. We also have the next one, we see a fraction. Can a fraction be in front of a variable or a couple variables? You betcha, okay? So we can have the digits in front being fractions. They can be negative fractions, they can be positive fractions. We know from our last unit with radicals, it could also be a radical in front. Okay? All right. 2, we have another one over here. That guy, we have variables, and there's a digit in front as well. Okay? And these guys each have exponents. Does the x and y in the green one have exponents? Think about it. What did we do in our last unit? If we can't see it, what's hiding? A 1. Good. So each of these actually does have a hiding 1 for an exponent. And so does the 2 coefficients. He's got a hidden 1 as well. Okay, so you can't forget those coefficients or the hiding 1s. All right, so one term, meaning they're sitting side by side with stuff. Okay, there's nothing separating the P and Q. There's no subtract sign or addition sign between them. If they're sitting side by side, okay, like a choo-choo train all connected, that means they're one together. One object, one expression, which means that is a monomial. Okay, that's why all of those are monomials. There's one expression. They're all sitting side by side, either multiplying or dividing. No plus signs or subtract signs between them. Now we go to binomials and trinomials. When we go to these ones, binomial has 2 terms. How come? The prefix bi, bi, means 2. Okay? Has 2 terms. Now, how do you know if it's a term or not? Who remembers from grade 9, how do we even know if it's going to be a term? Think about it for a moment. What is a term and how do we know it's going to be one? So, we just figured out if there's a plus sign or a subtract sign between digits or variables. That's how we separate terms, okay? So plus and negative signs separate terms. So can anything be a term? Yes. Any real numbers can be terms. Anything can. Variables by itself can be termed. Is X a term? You betcha. That X in front of the 4 there is a term. So is the 4. But the 4 is lonely. What doesn't the 4 have? Starts with a V. A variable. The 4 here doesn't have a variable. But does it matter? Is he still a term? Yeah, he's still a term. So this guy had 2 terms. That means it's a binomial. Bi is 2. Over here, 2xy, that's one full term because they're connected sitting side by side. The 3xy, or sorry, the 3y squared, same thing. They're sitting connected side by side. So I have a monomial and a monomial separated by a subtract sign, which creates 2 terms is a binomial. Okay? So anytime you put a plus sign between something or a subtract sign between something, you're separating terms. Okay? That's what's going on. All right. So now we've got trinomials. Again, I've got plus signs and subtract signs between them. Okay? That means I've got 1, 2, 3 things. The word tri in front, that prefix means 3. Okay? Just like a tricycle, 3 wheels. Okay? So, trinomial, 3 terms. All right? Again, they're separated by plus signs here in this one. They could be subtract signs or a combination of both. Okay? Now, it says a digit, a number that is in front. So it says multiplies to a variable. We want to say multiplies means it's in front. Okay? Multiplies means it's sitting in front of a variable. Okay? Of our variable here. And that's called the other C word we talked about, the coefficients. Okay? Co means in front. Okay? Now, polynomials consist of 1 or more terms separated with positive and negative signs. That's what we were talking about over here. They have to be separated by plus or negative signs. If they're not, and they're just all side by side, they're 1 term. Yes? Okay, it says a variable cannot be in the denominator if there's a fraction. Okay, if it's a fraction. That's one of the things that we have. That's a condition for our rules here. We deal with those in grade 11 and 12. We don't deal with them in grade 10. Okay, so we're going to keep our variables on top of fractions this year. All right. Write those down, and we're going to move on to the next section. Next page, if we take a look, it says explain if they're polynomials. Okay, if. Well, conditions. If it's not a polynomial, it might have an x in the bottom. There's also one other thing that it cannot be. We deal with whole number exponents. The exponents must be whole numbers. Whole numbers meaning 0 to positive infinity. That means no fractions, no negative exponents. Okay, none. So if we take a look at all these examples, some of them, yes, are polynomials, and some are not because they don't fit the condition. So if we take a look at the very first one, what is in the very first one? What do I notice I have? I'm looking to see, do I have exponents that are not whole numbers? No. These guys all have hidden baby ones on them. Okay, they're all whole numbers. So it checks that one. Excellent. Is there a variable on the bottom of a fraction? No, there isn't. So that means this guy, yes, is a polynomial. Okay? This one, however, the next one, if you take a look, what do we notice about its exponent? It's a fraction. We can't have negatives or fractions. So that means this guy is not a polynomial. Does it still exist? Yep. But it's called a rational expression that you're going to deal with in grade 11 and 12. All right. Over here, if we take a look, there's one more condition that we haven't written down. The last condition is there can be no variables under radical signs okay, no variables under radical signs with odd exponents. So odd number exponents. Okay, that's the other condition. If it has that, it's not a big no there. So, for example, if I had square root x cubed, could that be a polynomial? No, because the 3 is an odd number on the x. Okay, we don't call that a polynomial. Does it exist? Yep, we're going to deal with it next year. Okay, we dealt with it a little bit in our last unit with radicals. All right, but they're not given the fancy name polynomial. Okay, all we're right now finding is what is the name polynomial? What does it describe? And what would they look like? Okay, if we take a look at C, is the x4 under the root sign? No. Is there any decimals or fractions in the exponents? In the exponents? No. It fits every condition. So, can C be an actual polynomial? Yes. It can be a fraction polynomial. Now, what about D? What do you notice about D? What condition does it not follow? Variable on the bottom of a fraction. That's a no-no. To get the special name. Okay? So this guy's not a poly. Okay? Does he exist all day long? Yes, he exists, but he doesn't get the special name polynomial. Okay? Now, what if we have a term or a polynomial where we get lots and lots of terms? What if there's more than 3? We know that if there's 1, it's called a monomial. 2, a binomial. 3, trinomial. What if there's 4 or more? What do you do then? What do you call it if there's 4 or more? Good. So you'd state the number of terms. You'd say, okay, if it's 4 terms, you'd say 4-term polynomial. If there's 6 terms, you'd say 6-term polynomial. Okay, that's how those would work. You could also just call polynomial. How come? Poly in front of nomial. Nomial means numbers. Poly means many. So many numbers. Okay, that's what a polynomial is. But it's also dealing with variables. So, let's take a look at this one. Let's go on our chart here. All of these, they're telling us, are polynomials. Okay, they fit every description. They fit all the conditions. Okay, if we take a look, all of our exponents are not fractions or decimals, and they're not negative. If we take a look at the root sign here, the x is not under the root sign, so it's okay. Now let's take a look at number of variables. Okay, the number of variables. And we're going to talk about the number of terms as well. So how many variables do you see in the first one? Show me your fingers. How many variables do you see? In other words, how many different letters do you see? That many? Good, you see 3 of them. So there should be 3 different letters, X, Y, and Z. All right, how many terms does it have though? 2, good, there's 2 terms because they're only separated by a plus sign. So there's 2 terms, one on the left, one on the right. What kind, if it's a 2-term, what kind do we call it? Binomial. All right, the second one. How many different variables do I have? How many different letters do I have? Back row. How many different letters do I have in the second one? 3, good. Now, how many different terms do I have? Show me your fingers. 3, good, there's 3 as well. How do you know? Again, look for the number of subtract and plus signs. There's 2 of them, so there's always 1 extra hanging on at the end. Okay, so 2 signs you're going to see, 3 terms. All right. Take a look at the next one. Oh, we didn't call it. Sorry, we didn't name it. What type of name does he get if he's three terms? This guy said he was binomial for 2 terms. How do we call 3 terms? Trinomial. Good. Tri, because tri means 3. Okay, that's a trinomial. Check out the green. If you can't see the green at the back very well, I'll switch out greens. We'll do this one in green, see if you can see it very well, okay? Sometimes you can't. All right, how many terms, or sorry, different letters, how many different variables do you see? How many different letters? 1, there's only X. This guy has a different exponent than this guy, but the letter's still just X. Okay? So, X, so it's 1. We have 1 variable. Number of terms. How many terms do we have, though? Show me your fingers. How many do you have for terms? We've got this one, and that one. So how many do we have now? 3 terms. Okay? 3 terms. We already know from that one, it's going to be a trinomial. How's the green? Can you see the green back there? Is the green okay? Yeah. All right. Let's go back to red. How many variables do I have in the next one? How many letters do you see? How many variables? 1. Good. How many number of terms do you see? Let's check our rule. Are they attached, sitting side by side, or is there a plus or subtract sign between them? They're attached side by side. They're attached side by side. They make 1. Okay, oops, I'm slow. They make 1 term. So what's a 1 term called? Monomial. Okay, the mono means 1. All right. What do you see in the next one? How many different variables? And again, by variables, you're counting the different letters. How many different letters do you see? 2. Good. So we have an X and a Y, so we have 2 different ones. I just listed them just so you know. All right. And how many terms do you see, though? 4. Good. Excellent. How come? We got a plus sign here, and a subtract sign. 3 signs between, you're going to have 4 terms. Okay? 4 terms. We already discussed. How do we call this one? No, it doesn't get the quadnomial. We would think it might, but it's not a quadnomial. What do we call it? A polynomial by itself? Sure, one, we could just call it polynomial. Or we could put something else in front to describe it. What else can we put in front? 4 term. Good. So 4 term polynomial. That's just more descriptive. But does polynomial by itself work? Yes, it does. Okay, I'll let you finish writing that down, and we'll get started. Just pause now and play when you're ready. Okay, we have polynomials with 1 variable. Okay, 1 variable only. They are arranged in descending order. Now let's think about what the word descending means. If you're going to descend, what do? You go down. Good. So that means descending order means small to big. Okay? Small to big. They are usually arranged in that order. Small to big. Or sorry, I'm backwards on that. What am I saying? Big to small. You're going down. Pardon me. Big to small. Big to small. That's what we're doing. So descending, we're starting big, and we're going down to small. What they're talking about is the exponents on them. Okay? That's what we're talking about. Big to small exponents. Okay? So we look at the digit, the number on the variable, as an exponent. So we're going to look at these ones. If I grab my blue here, we're going to look at that, and something special about this one. All right. What do we know is hiding on the 2x? I hidden 1. I've got a 1 there. So the ones I need to arrange are the guys with the exponents. Now, 7 does have an exponent. Okay? He's got a hiding 1. But he's called a degree 0. Degree 0 means he's got no variables. So the guy with no variables always goes last. He's not invited to the party. Okay? He stays home. So we're going to start with the 3. 3 goes first. So we're going to write negative 4x cubed. Now, why did I put that negative sign with it? Who knows why I put the negative sign there? Who knows why the negative sign belongs in front of that 4? How come it doesn't just go after that 2x? There's a rule there. Exactly. So if you remember from grade 9, we had those algebra tiles, and I put them on the board, and they were red or they were green. And in your textbooks, they were yellow or red. Now remember, the negative and positive sign tell you what color of object you have. If it's a negative, that means it would be a red one. Okay? So that means this guy is a negative. It also means that the sign in front goes with the guy after it. Sign in front goes with the guy after it. Sign in front goes with the guy after it. Well, what about the 2x at the front? What kind of sign does he have? Right. If you don't see it, it's always a hidden plus sign. If it's a negative, you will see the negative. Okay? So, we're going to have negative 4x cubed. Who goes next to him? Who's second? Who goes second right after him? The 6x squared. So can I just write 6x squared like that? I need to put the plus in. Now, why do I have to put that plus sign in? There's a rule. It's a positive 6x, absolutely, but there's another reason. Beautiful, absolutely. If this was cuddled up to that blue stuff without that plus sign there, when they sit side by side, they mean multiply. And that's not what's going on here. So you have to insert the signs between them. Because remember, that also tells us how big our polynomial is. This one is a 1, 2, 3, 4 term polynomial. If I would have stuck those together, that would have been one full term together. And they're not. They're separate. So we need the plus signs and subtract signs to separate them. Okay. So now, who would go after the 2? Remember, we're going in terms of these exponents. What type of exponent would go next? Good, the 2x. So again, do I just go 2x with a plus sign between? Good. Now, you don't have to show his 1. His 1 on his x can hide. That's okay. All right, who's the guy at the end that can't go to the party? The negative 7. Don't forget, he's got his negative. Okay, that negative sign goes with the 7. All right. Perfect order. 3, 2, 1, and nothing. No variable. That's how you put them in order. Now, just for giggles, they want us to do it backwards. They say, now put it in ascending order. All right. What do you mean ascending order if descending goes down, big to small? It's small to big. It's the exact opposite. Okay? Everything in math has an opposite. Okay? So you guys write the first part here in A, write it backwards, please. And then I'll write up the answer and see if you got the same thing as I did. Push pause now and play when you're ready. Okay, let's check your answer. You're going to have the negative 7 first. Then you're going to put your plus 2x. Then you're going to put your plus 6x squared. And last, you're going to put your minus 4x cubed. Check your work. All right. Letter C says leading coefficient. We need to know what the heck that means first. Leading coefficient. Leading means in front. And so does co. So what is a leading coefficient? It is the largest, let me rephrase that. It is the digit in front of the variable with the largest exponent. Okay? So the digit with a variable which has largest exponent. Okay, so the biggest exponent. So if we look up here, which exponent is the largest on our x's? Look at all your x's. Which one's bigger? 1, 2, or 3? 3's biggest. So we look in front of him, and what's our number? Negative 4. So we would call negative 4 is our leading coefficient. Okay? I just write really big, guys. Sorry. I hope you can fit it on your page. Okay? So leading coefficient has to be the negative 4. Well, you put the x3 with it. That's okay. But the actual leading coefficient part you have to understand is the negative 4. Okay. Why is it? Okay. The rule is you look at all the variables. Who has the biggest exponent? You have a 1 small, a 2 small, 3 is the biggest. Okay. So the guy in front of the biggest exponent. All right. Constant term. If you were in my math class last year, you always heard me talking about the constantly lonely. They're lonely because they don't have any fun with the x's. So, yes, what kind of 7 though? Negative 7, beautiful. So these guys have no variables. Okay, no variables, we have negative 7. All right. Coefficient means number in front, and it wants the number in front of x squared. What is the digit in front of x squared? 6. Beautiful. Now, if those were all positive numbers, let's pretend this would be a beautiful numeric response question. It might say, put this answer in the first box. Put the next answer in the second box. Put the third answer in the third box. Okay? So it's a beautiful numeric response question if they're all positive. Okay? So they can be worded this way. You have to be aware of how they're worded. Okay, let's move on. Now we're going to do it with algebra tiles. So we've got green and white. White is going to be our negative. Okay? So green's positive, green go. So it says, use the algebra tiles to determine the result, which is the answer of adding these. Well, if I'm going to add them, how do you know how many you have? Well, we're going to draw them. So, the first one, I've got 2 big green boxes. That is my 2x squared. Okay, my 2x squared are my 2 big boxes. Okay, that's that part. My plus 1 is my baby little green one. Okay, those little baby squares, those are your constants. Okay, the constants are the baby squares. This guy's our plus 1. All right. Now we've got an x squared again. There's a hidden 1 in front of him, so we know we've got 1 of those. We take another big green box. That's our x squared. Now we got some negative stuff. Now, for you guys in your books, you might just want to shade them, okay? If you've got highlighters and you like to work with highlighters, use your highlighters to color them. That's fine too, okay? All right, we're not quite done. We've got a negative 2x. That's what I'm saying. You have to watch because the negative and positive signs tell you what color they are. This negative sign in front of the 2x tells me that it's going to be a white one because white's negative here. Okay, so I need 2 long sticks. The long sticks here are the x's. Okay, so the long sticks are those x's. This is that's my cloners. Now this negative 3 here, does it have a variable? No, he's my lonely one. So he's these little baby boxes. So I'm going to have how many baby boxes? 3. Now, when we add them together, we do what's called 0 pairs. You make 0 pairs. Okay? 0 pairs means it takes 1 from each color and they cancel. Do I have any size that has the opposite colors? The small ones, right? So I can take this guy out and this guy out. They make 0. They're gone. Okay? I can take them out. Now I'm going to make my answer. This guy becomes part of my answer. So I've got 1 big x squared, I have another big x squared, and another big x squared. Instead of shading them, some kids like to put positive and negative inside them. That also works if it's your strategy. So some kids won't shade it, they'll just put plus x squared. That means it's a positive. Okay, if it was a white one, they put a negative x squared. All right, how many big green boxes do I have? 3. So my answer to all this, I have 3 big green boxes, 3x squared. Okay? How many long sticks do I have? 2. What color are they? White, so they're negative. So I'm going to have negative 2 x's. Okay, negative 2 x's. The sticks are the x's. Okay, those are, I call them sticks. All right, 2 new guys. What are they going to do? What do I write at the end of this one?
Negative.
Oh, negative or subtract is fine. Negative 2. Good. That means I've got all of those. That's what this answer is going to give me. Now, could I have done that by just looking at these and matching them up? Yes, you could have. Absolutely. Okay, we're going to do practice questions like that. All right, almost done this lesson. Push pause down, play when you're ready. We can also add them. If you don't want to draw the tiles, drawing the tiles is easy for some, and some choose to do that. If you don't want to draw the tiles, you can do a couple other strategies. Here we go. We can do this by doing 2 different strategies. If you like highlighters and colors, you can highlight the ones that match. It's basically a big matching game. And then you add the numbers in front of the variables. So, or another strategy is to put different shapes around them if you only have a pencil. So you could put a triangle around the A's. There's another A. I'll put a triangle around my A's. You could use colors. I could put a box around my B's. And I could put a circle around my C's. Okay? So you can use different shapes if you just have a pencil. You could use colors if you have a variable. And now that you've got them matched, all you do is you write down absolutely everything that you see here. So, on the blue ones, I've got a 3 in front of my A, and over here I have a negative 6. So I'm taking 3 plus negative 6. What does that give me? A negative 3. So my blue ones, I'm going to have a negative 3 A's. Okay? I added them, they're done. So now if you want, if you're the kind of person like me, you kind of cross off things when you're done so you don't have to look at it and it's not messing you up, I'd cross them right off. Okay? They're done. Now let's deal with our red boxes. We've got B's. I have a negative 4, and I'm adding 3. How do I know it's a plus 3? Because there's no negative sign in front of them. They have to show negative signs, so if there's no negative signs, it's automatically a positive. So, I'm going to take negative 4 plusing 3, I get a negative 1B. Now, a lot of you are going to say, Miss Tuff, you don't have to show that 1. No, you don't. You can hide it. It could be just a little 1 in front. Okay? All right, let's do our circles. So we're done with our B's now. They're done. The last thing we have is our C's. I have a positive 5 and a negative 5. What do you know about positive 5 and negative 5? They cancel completely. So do I write plus 0 C's? Do I? If you have nothing, if you don't have any of them, you just don't write them down. They're gone. They cancel. Okay, they're gone. Because if you remember back here, when we had opposite ones, these little tiles, we took them away, and they were not in our answer. Same thing goes for these questions. You take them away, they're not part of your answer. So our final answer is going to be negative 3a minus 1b. Okay? Or you could put negative 3a minus b. So you could also write it like this. Negative 3a minus b. That's also correct. Because that one can hide. Okay? Alright, we're going to try it with this one. Now this one's kind of crazy because the exponents are all over the place. So, a like term, we're talking about like terms. Like terms can only be same base, same exponent. So that means if you've got more than one variable sitting side by side, in order to match them, they have to have identical variables. So, on this one, I've got a squared and a b to the 1. he can only add to the a squared b1. Do you see any other a squared b1s? Yes, where do you see it? At the very end, good. So we see an a squared b1. They can add together. So when we add them together, we add the digits in front, the coefficients. I've got 5 of these guys. What's hiding in front of this one? A 1. What's 5 plus 1? 6. So I have 6 a squared b1. Do I have to show that 1 on the b? Nope, he can hide. Our 1s can hide. All right, we're done with those guys. If you want, cross them off. Our next one shows us a exponent 1 and b2. Are there any other a exponent 1 b2s? Yes. Where do you see it? Right here. Now what do you notice? They're both negative. That's okay. You're adding negatives. So you have a negative 1 plus a negative 7. Where do you end up? Negative 8. So negative 8, a1, b2. Okay, we've taken care of those guys. They're done. We've done the green ones. We've done the yellow ones. Well, what do you know? Does this guy have a partner to add to? No. So what do you do with them? You just chuck them on the end. You betcha. It's like your little brother or sister that's always tagging along. You just chuck them on the end and they tag along. So we're going to put plus 4a3b. Okay, he didn't have anybody to add to, so we're done. Now, can I add all of those together? What did I do? Let's do that. Undo. Okay. I threw him away, I think. All right. Can I add all that together?
Yes.
They have the same variables, but the one condition they don't have is they don't have identical exponents on them. A2, he's an A1, A3. They're different. You cannot add them together. Okay? Because an A1 is different than an A2 or an A3. None of those are identical. You're done. These guys look pretty similar. You have a hidden one there and a hidden one there. All they did was they changed who had the 2 and who had the 1. But it doesn't mean you can add them because they are different. That'd be like oranges, apples, and bananas. Can't add things that are different together. Is that your question?
No,
Now we're going to subtract. When we subtract, it says subtract this guy from that one. So we're going to write it like this. Subtract, and you put it in a bracket. 3x squared minus 2x plus 7. There's a couple different strategies for subtracting. What you can do is you can write it underneath the one it matches. So this guy is an x squared. I'm going to put him underneath the x squared. So I've got 3x squareds. He's a positive here. I need to subtract him. Basically, you do the opposite sign. 5x. The x here matches. So a negative 2x is going to match this guy, but I have to subtract a negative. What's subtracting a negative going to give me? Positive. So I have a positive 2x here. And on the end, I have a positive 7. How am I going to put a positive 7 under here? Subtract 7. So you do all the opposite signs. Now you put a line underneath and add top to bottom. When you add top to bottom, you're only adding the digits in front. So here we're adding 6 and negative 3. That's going to give us a 3. Drop your x squared down. He goes for the ride because he's attached. The next one, we're going to add the negative 5 and the 2 to give us a negative 3. And the x comes down for the ride. Lastly, we've got our constants. We're going to add them. Negative 2 plus negative 7. If you're confused about negative numbers and you're trying to do it in your head, please check your answers on your calculators, because sometimes we do opposite operations with our negatives. You could also think of it as money. If you remember in grade 9, we talked about money. You owe $2, you owe 7 more. How much do you owe in the end? $9. So it's a negative 9 because you still owe it. Okay? All right, that would be our final answer. We cannot add these together. He's a hidden 1. The reason we can't, if you look back at here, they're all different shapes. This is an x squared shape. That's an x shape. And that's a constant shape, like just a digit. He's a digit. So we can't add them together. They're all different. They're different shapes. Different shapes can't add together. Last question. We want perimeter of a square. Well, we know squares have all the same side. So we would draw a square, and they're all the same side. If you put a little tick on them like that, that means they're identical. It tells us my sides are 2x minus 3. 2x minus 3. 2x minus 3. Drawing an example is a good way to demonstrate your learning. So, if you take a look here, all you're going to do now is if you got a highlighter, or if you want, you can circle them. All you do is you add the things that are identical. It's a matching game. 2x plus 2 more, plus 2 more, plus 2 more. How many x's should I have? 8. Good. So equals 8 x's. Now we can take a look at our digits. I have a negative 3. I owe $3. Hang on a sec. I owe $3. Yes, mister with the crutches, you can go. I owe 3 more. Okay, we're going to add up all those negative 3's. Let's continue. Negative 3. You owe me $3. You owe me 3 more is 6. You owe me 3 more is $9. You owe me 3 more is 12. So since you owe it, it's a negative. So negative 12. Okay, that is perimeter of a square. This concludes lesson 1, 2.1 of polynomials.